Assalamualaikum and hi. Today our group will talk about chemical analysis in food safety. So first, let's talk about food safety and why it matters. Food safety is all about the step we take to make sure the food we eat is clean and safe for our bodies. It is designed to stop people from getting sick from harmful biological, chemical, or physical things that might get into food while it's being made. Why it is important? Because it helps to protect everyone's health and keep people trusting the product they buy. It helps us find harmful things in food, make sure companies follow the rule and keep food consistent in quality. Plus, it ensures that the nutrition level on the thing we buy are actually accurate and safe. So next, let's look at how we check for safety using chemical analysis. This is a lab method used to find and measure chemical substances in food like pesticide, toxin, or heavy metal like lead and mercury. So, by using techniques like chromatography or testing, we can check if food is safe, see what inside it, and verify that the levels are correct. So, the statistics of foodborne illness are quite serious. Worldwide, about 600 million people get sick from unsafe food every year, leading to over 1.5 million deaths. Unsafe food can cause over 200 different diseases such as infection or diarrhea. So, about 143 children passing away from this illness annually.
Chemical analysis is used to identify and measure the substances present in food. For fruits and vegetables, chemical analysis is used to measure nutrients, pesticides, residues, and heavy metals. Techniques such as chromatography and spectroscopy can detect these substances accurately. This is important because excessive pesticide residues or heavy metals may be harmful to the human health. In milk and dairy products, chemical analysis is used to determine the levels of proteins, fats, lactose, and possible contaminants. It can also detect antibiotic residues that may remain after animals are treated with medications. By identifying these substances, chemical analysis help maintain product quality and protect consumers from potential health risks. And last but not least, for grains and nuts, chemical analysis is used to measure nutrients, moisture contents, and contaminants such as aflatoxins, which are toxins produced by mold. High level of aflatoxins can be harmful to the human health. Therefore, chemical analysis is essential to ensure that grains and nuts are safe for consumption and comply with food safety regulations. Fruits and vegetables may be contaminated by pesticide residues, heavy metals such as lead and cadmium, and harmful microorganisms. These contaminants can come from pesticide used during farming, polluted soil or water, and improper handling during harvesting and transportations. Next, milk and dairy products may contain antibiotic residues, chemical contaminants, aflatoxin M1, and heavy metals. These contaminants can originate from medicines given to animals, contaminated animal feeds, processing equipment, or post-storage conditions. Lastly, grains and nuts can be contaminated by mycotoxins, especially aflatoxins, which are toxins produced by molds. They may also contain pesticide residues and heavy metals. These contaminants can develop during cultivations or improper storage in warm and humid conditions. Chemical analysis is used to detect these harmful substances and ensure that grains and nuts are safe for consumers.
Now, I will be presenting the methodology of chemical analysis in food safety. The methodology begins with sample collection. A representative food sample is collected to ensure that the test results accurately reflect the entire product. Proper handling and storage are important during this stage to prevent contaminations or chemical changes that could affect the reliability of the analysis. After collection, the sample undergoes preparation before testing. Depending on the type of food, the sample may be ground, filtered, or extracted. These procedures help obtain a uniform sample and isolate the compound of interest. Proper sample preparation is essential because It improves the accuracy and consistency of the result. Once the sample is prepared, analytical techniques are used to identify and measure chemical substances present in the food. High-performance liquid chromatography or HPLC is commonly used to separate and quantify compounds such as vitamin, preservative, and food additive. Gas chromatography or GC is useful for detecting volatile compounds, including pesticide residues. Spectroscopy helps determine the chemical composition of substances by analyzing their interaction with light, while mass spectrometry provides highly accurate identification of compounds based on their molecular characteristics.
And now, for example of the results. First, we have nutrient verification. Keeping label honest, when a product claims it's high in vitamin C or low in sugar, we use HPLC to prove it. This machine separates a liquid sample into its individual components, giving us a precise chemical fingerprint. It ensures that the exact nutrient levels printed on the packaging match what's actually inside. Second, we have fat and aroma profiling GC. For quality and flavor, we use gas chromatography, vaporize sample like oils into a gas to separate their molecules. This lets us map out precise fatty acid structures, proving your premium olive oil is not a cheap substitute, while also identifying the volatile compounds responsible for food aromas. For point number 3, we have contaminant detection mass spectrometry. Our ultimate line of defense against hidden hazards is mass spectrometry. This incredibly sensitive tool weighs molecules at the atomic level. It catches trace contaminants like lead, mercury, pesticides, or mold toxin down to parts per billion, ensuring nothing dangerous slips into the food supply. And lastly, for quick high-volume testing, we have spectrophotometry. By shining specific wavelengths of light through a sample, the machines measure how much light is absorbed. Because absorption correlates to concentration, it lets us rapidly calculate core building blocks like proteins, carbs, and phosphorus. To conclude that, chemical analysis is the foundation of modern food safety and regulatory compliance, bridging advanced laboratory techniques like mass spectrometry and HPCL with consumer trust. By accurately verifying nutritional labels and identifying trace contaminants, these testing frameworks protect public health while shielding businesses from devastating legal liabilities and product recalls. As global regulation tightens and consumer demands for transparency rise, robust chemical testing will remain the essential gateway to ensuring a safer, more sustainable, and highly compliant global food supply.
I just had to let you know you're